There we go. So, welcome everyone, or the people watching at the delayed time. This is yet another session on the physics. I think this one's for the external. Is that correct, Aaron?
It is indeed.
There you go. The external on energy. And Aaron's going to walk us through some amazing things that he's done. So I'll just flick it off to Aaron. Go for it, my friend.
Okay. Let me just to move things around a little bit. Can you see a presentation from me?
Yes.
Good. Okay. First of all, tēnā koutou I hui hui mai nei. Welcome to all gathered here. Ko Aaron Huber, tōku I noa, ko Pakiha aho, I tipu ake aho ki te motu o Waiheke. I raro o I te maru o te maunga e rangihoa, ko te kapa I te moana, te ori aho no Horana, no Awherika ki te tonga, ke te noho au ke Tamaki Makaurau, tēnā ka mihi, thank you all. So that was just so you can get a bit of a look at me and create some connections with me. I'm a first generation New Zealander. My parents came here, had some kids. I'm totally new to all this. So this is, I'm new. I'm a new person in New Zealand. I grew up in a small school. So my experience is a small school, but I'm working in a very, very large school. So when I'm speaking, just know that I'm coming from this. I'm trying to teach or create something for a massive school. So the standard that I'm focusing on here is demonstrate understanding of the physical system using energy concepts. What I plan to go over is the purpose of these lessons, how to actually use these lessons. What we tried to jam in and pigeonhole into these lessons, the scheme, we always have one, what a typical lesson will have in it, what a practical lesson will have as well, and what these magical optional lessons that I've jammed in there that you might have seen in the scheme. So these resources are designed so that any teacher, whether they're a totally not experienced teacher, a new teacher, an international teacher, it doesn't matter. Like they should be able to use these resources. No teacher should have to reinvent the wheel. Okay. And that's always the case. We should be able to have something mostly provided to us. And this is my gift to the people. But before I go a little bit into this, what I want you to do, yes, I want you to be a little bit more involved. And I don't even know how many people are in here now. I'm hoping more than 10. But I want you to put one word in the chat that describes how prepared you felt for the standard on the first day of school this year. Okay, so I'll say that again. One word in the chat. I want everyone to do it that describes how prepared you felt for the standard on the first day of school. While you're furiously doing that, I'm just going to continue. So feel free to see if you can multitask and listen and also type one word. If you're a student, I'm going to say you can't, but all right. So how to use these. First of all, you find these resources in NZIP. They're in the level 1 resources named under the standard. It's a bunch of stuff. I think it says Avondale resources. You'll see a whole bunch of lessons, and there is at the bottom a read this document. You read it. Most of the stuff it says will actually be covered in this presentation. You do what every teacher always does: steal what you want, right? Steal it. Go nuts. And make up the rest. You are a teacher. Do it. You'll see lessons that look remarkably like this. Okay. It is a gigantic bunch of very linearly organized lessons and folders for each lesson. There is actually about 4 more optional ones at the bottom. It's taught super linear, like the first, 9 lessons are mechanics. And then we have about 4 for electricity. Note that there's only 4. There's not that many because Ohm's law is not even mentioned. And then about 8 or 9 lessons on energy, on thermal energy, and a bunch of optional ones at the end that I'll talk a little bit more about later. So what we actually tried to jam into these lessons, and over the years, from every direction, they're telling you that you have to try to add these things to lessons. I've tried in all my ways to put in all of them miraculously into these one lessons. The first two are actually super awesome and important. Mataranga Māori, Māori knowledge, we want to put that in there. Te reo use as much as we can. We want to be doing experiments, and so that you're not lost, worksheets that actually go with that experiment. Demonstrations, probably not as many as Dave Thrasher. He's got like 18. Like, feel free to put in more. I've got a few. Digital activities, so that kids are actually using their devices or computer rooms. Literacy activities, so that kids are learning to read. Numeracy activities, so that kids are learning to count. Misconception targeting type concept cartoons, so that we can just target misconceptions because they're all over the place, possibly given by the occasional teacher, but anyway. And actual instructions of how to use that lesson or that equipment or that. So, my trusted sidekick, Dave, because I can't even see the chat. Dave, can you read me what words we have for how people felt
Well,
first day of school?
we have the occasional fraction, like 2 out of 5, but you've got 0, you got terribly, you got not. I like that. You got unprepared, another 0, a 0. I like the YOLO. That could be interpreted different ways. Partially, not, and no. So a lot of almost nils.
Almost nils. I think that kind of makes sense because those would be the people that we'd see here today. So this gift is to try to change that view for you. To be fair, like, it's been a few weeks, so maybe you've miraculously created a course in that time, but maybe not. These resources are for you. So you will find a scheme, and you've all seen schemes before. Sorry, I might be telling you how to suck eggs, but anyway, it's a scheme. You'll see on the far side. It'll go in logical order in terms of the actual lessons, just saying lesson 1 all the way through to the end. But those magical little optional lessons are jammed in there, and they actually say where you could put them. It says what the specific learning outcomes are for that lesson. They are basically the ones provided by NZIP / the government. Occasionally there might be one or two others, but mainly those are the ones given. There'll be a hey mahi, bit of details about what the student or the ākonga will actually learn during that lesson. And one of the main things in that explanation of suggestions part is the key idea for that lesson. And it'll always have that for every lesson. For example, this one's on conservation of energy. Energy is never lost or destroyed, just changes from one form to another. Next column just says some of the content or types of content that might be in that lesson. That's more something that I had to do for my school. So this one has Māori knowledge and literacy and also a digital activity. On the far right, just like most schemes, it shows you what resources there are. This one everyone has a PowerPoint because it's a very PowerPoint heavy course. And it uses a simulation for energy bar charts. And might add the links to the videos in there. What I also put in there was quite often, and I plan to add more, videos which link to like the actual NZIP videos, which talk about the materials. So that if you have no idea what you're doing or your teachers do, they can look at those videos and go, okay, I get it now. Let's teach this. I'll be one day ahead of my course, just like we never do. So what a typical lesson may or should have. It'll have a teacher booking, printing, and planning page. It'll have a hey mahi, which is a do now. It'll have curriculum links, mostly the same as the ones given. It'll have some notes, some activities. It'll have a page that says put some problems here, maybe. If it needs it. It'll have some type of plenary, which is the last bit, and it might have a note for flashcard creation for kids, and it possibly may have a glossary, but to be honest, I actually intended to do that, and it'll be in a few lessons, but it's a good thing you should do it, because I actually didn't do it for most. So that was kind of anyway, moving on. So the lesson I'm going to use as this example does have a chunk cut out of it. So know that if there's a chunk missing, it's not a full lesson. I'm not going to talk you through a whole lesson. But here is what a teacher booking and planning page looks like. So it'll say number of lessons, 1. It might say 1 to 2 because it's a lesson which is really big or would be good to spread over to a couple of lessons. It says book this because every kid needs a device or every group needs a device. So you may need to book a computer lab or make sure that they actually bring, like if your kids are like my school, make sure their devices are actually charged or they tell them to bring them, right? And you'll see in the lesson later on, there'll be something more in that print resources. This is an example of a literacy Hey Mahi. So just has a bunch of questions. What I'm more pointing out with this is that whenever there is questions, because I know that not all teachers are physicists, the next slide will actually have the answers, right? Because me assuming that you're going to have the answers in a physicist way of thinking about it is probably a bit of an overassumption on my part. I'm going to give you the answers that I like you to be confirming with the students. Although this is just a literacy activity. This is an example of your curriculum links page. I mean, you're not going to do much with it, probably apart from move on. The main thing I want to point out is that it'll always have the date in Te Reo, and in English, and it'll have the learning outcomes on the left. The other thing I wanted to point out was that on the far top right, I don't know if I'm pointing the right side, left or right, you see a smiley face. Now, if you've ever taught with PowerPoints and you have kids who sit there furiously trying to write down every stupid word on your PowerPoint, that smiley face is something that I've done. You can totally ignore it, but it means don't write anything. Just listen, right? So it's just a smiley face. Just listen to these words. Although ironically, some people do actually like their kids copying down the learning outcome. But I put a smiley face there so that kids are actually listening and they can put their pen down and they're not trying to scribble down all the things that I say. As opposed, I was going to say the learning outcomes on the left, they are the ones as given. If you're super into solo, you may want to actually soloize them to scaffold that learning. But those are like often quite intensely stated at extended abstract, or point is high level. So you may want to scaffold those yourself. I talked about the smiley face at the top. This is the other one. It's a righty hand, right? This says there's something on this page you should probably write down. And I got to tell you, my kids are a little bit lazy, so I often go, that's the bit in the big red box. So energy conservation. Energy is never lost or destroyed. It just changes from one form to another. And like, write it down. Say it all the time. But what that actually means is this, right? That the total energy in the system is always constant, unless energy somehow enters or leaves. So you'll see that on any time when they have to write something down. Feel free to use it or not. It's something that I use. I just like that. Put it in there. Moving on. All the energy in the universe since the Big Bang. It's still there today. This is an example of some type of video or GIF. You'll often get, quite like having GIFs which just cycle over and over and again, and it's really short, and it kind of shows a bit of an idea. For example, this is Jim rolling down a hill. Is his energy conserved, or does energy change into different forms? Those type of questions. And again, it's to promote discussion. Of course, I'm going to put answers on those on the next slide so that my teachers can actually have those discussions and know what they're talking about. This is just something which is cool, and you should try it, by the way. This particular lesson actually uses energy bar charts, this particular simulation, but this is what we do in this lesson. It's a really cool example. I end up using this in 2 different lessons. But moving right on. Where am I? Why is it not going? There we are. This is an actual video, which I'm not going to play, with questions, so that you can see that it's very similar to the GIF page. Okay, so this is one of those ones I was talking about. Placeholder right here. I wanted these resources to be non-book specific. So if you have any resources that you use, any textbook that you've decided is the best one to use, I'm not saying you should buy any particular textbook. I have a particular book that we use at my school. In my version of this, I'll probably have some page numbers right there. But this is where, if you ever find these, there's like 15, 20 minutes for you to do some problems on a worksheet or a textbook. I recommend putting in some page numbers there. If you have multiple classes, I recommend putting it there so your teachers know which pages to look for. This is something which a bit of an initiative that I did with my lessons. At any lesson where there's a definition or a principle or an equation which the student should remember, I've got this at the end. You could use it or you can throw it away. It's quite a good thing that if you put your PowerPoints onto Teams or Google Classroom and the kids go through them later when they're creating their flashcards, they're on there to kind of point out to them, this would be a good point to actually write down that flashcard. What conservation of energy is, and on the other side, what it actually is. Okay, now before I give you this next task, one thing I forgot to mention is my school's big. It's got 20-ish science, like year 11 science classes. 8 of them were at school that does Cambridge and NCA. 8 of those Cambridge. I've got about 12 which are NCA, and those 12 classes are actually going to be doing this course. We're doing the chemistry, physics, bio, and earth space type split. All of those 12 classes, 3 of them will be specialist physics teachers, and of those other 9, they are obviously chemistry and bio. There's 2 brand new teachers from a different country. There's 2 students who have just started for this year. Like everyone, like there's new in all directions, right? So I'm creating this resource in the mind that I need those new teachers and those teachers from different countries to be just given something that they can use. And I can help them with the little bits, but not have to be trying to work on everything and all the other things. So that's kind of my mentality behind these resources. Okay, your next task. Put one word in the chat that describes how you feel this NCA process has gone so far, this NCA change process. So one word in the chat that describes how you feel this NCA change process has gone so far. Dave, you just wandered away. David Thrasher, this might be the bit of the presentation that you cut because it's you won't be able to put it onto YouTube. When Dave does the reading of the words, like you might just
I'll do the self-editing. Don't worry about it.
yeah. You can edit out those ones. You can edit those ones, but we'll read those words in a second. I'll give you a little gap. So one word in the chat that describes how you feel this NCA process has gone so far. Okay. Practical lesson. I just want to point out what is one of the things that practical lessons have, which normal lessons don't have. Practical lessons will have generally a worksheet, right? The other lessons just have a space, like a placeholder. All the experiments have a worksheet that go with it. It'll have more detailed teaching, booking, printing, equipment, and planning page, maybe even some timing hints, because you need more. For me, I'm going to put a link in there with the risk assess for my school. I haven't made them yet. There's very often, if it's a complicated experiment, there's explanation slides for you so that you actually know what you're doing with this equipment that possibly you just bought. You're looking at it and going, what do I do with this thing? There's explanation slides for them so that you can talk through the students like what you're actually doing in that experiment. Often those two are actually the same thing. There's always or generally some questions or answers related to that actual experiment. Here is a few of those examples. So a bit more of a detailed teacher booking and planning page. So here it says book this, and it's a list. You need these things. If you don't have them, I recommend looking ahead and actually buying some of these things, right? It tells you if there's like, because I've written, or we have written, worksheets to go with this, print them. It's a 2-page double-sided thing, print it. And this one here probably should have been written 1 to 2 lessons because it's a very full lesson and could be done over 2 lessons. So those types of hints will be there for the teacher. This particular lesson, which is on, I'll show you in a second, has some timing notes just to make sure that you know that it's really full. So if you're a new teacher, you can kind of go, I should be spending about this much time on my things. Before I show you the next slide, I just wanted to say what this experiment was so it makes sense. It's the good old, there's a car at the top, it's going down. There's going to be 2 experiments in this. The first one is literally changing the ramp height and seeing how far the car rolls. Super easy experiment. And in that PowerPoint, there'll be something like this going, a really interesting way to actually create different heights on a ramp if you don't have thousands of spare books sitting around is maybe actually just measure the different parts of a chair if you have them and use those for your ramps, right? So something like this will be in the PowerPoints too. There'll be some type of picture of a setup, for example, the ramp experiment. So it's rolling down, you're measuring how far it goes. Don't look at the maths on the board in the background because the kid wrote it and I think it's wrong. And then experiment 2 talks about going down the slope and showing an actual way to measure the velocity at the bottom, right? So having some type of computer at the bottom with a timer on it and like videoing it as the car drives past. So you've got the timer in the background and you can measure the speed at the bottom. So you can do a potential energy to kinetic energy. So a little bit harder experiment is the second one. And then if you're lucky, there may be like a slide showing you what type of problems may happen when doing that experiment. So in this particular one, if the car hits the sides going on the way down, you may want to switch cars or do it again. But this type of page could be useful for you as a teacher just to see what problems are coming along, but it might be something that you actually keep in there for the students. Changing experiment. So this is one which one of my work colleagues designed, and I think it's really cool. It's calculating the specific heat capacity of rocks, so honey stones, right? Because there's quite a few steps to calculating that specific heat capacity, like there's about 4 or 5 pages talking you through the steps with the PowerPoint, right? So that you know, and also the student. There's also a printable instructions page which you can laminate so the kids can be like, all right, I can follow this step by step. But this is a really cool experiment. The one thing I will say is I think there might be rules against you running down to a river and picking up lots of stones to use for this experiment. I think you're not allowed to. So, but you can go to like the landscape yard and get a big old bag of rocks to use. More examples. So there's one which it's the classic thermal physics type circus of activities. There'll be like 5 or 7 around the room. We've got like 7 of them in this thing. And if you try doing one lesson, you'll probably never make it to the end unless you have long lessons. But it's trying to cover heaps of different examples of different things that you could do as demonstrations. Feel free to get rid of what you don't have, or keep the ones or buy the ones that you want, like from places, because maybe that's a good idea. Maybe you do want to buy one of those weird square things with the convection water, which is actually a really cool demonstration, but you're never going to have more than one. But I'll tell you what you have a lot of is tea bags. And that's like another really good convection type experiment. And that's in that circus, as long as you're happy with lighting your room on fire. Okay.
Oh, Aaron, I do have, I'll interrupt you just for a heartbeat here.
Go.
Somebody did ask a great question, and I bet you he's not the only one to be thinking this while you're showing us the package and the details thereof. Did you create this in 1 year? this year over your holidays? Have you already rolled it out? And if so, have you learned anything by rolling it out, and what other teachers are using it and how they're using it?
Cool. Uh, First thing is we had a decent chunk of time. It's good old term four, like after about week 2 to 3. Any gaps, like I had a meeting with my teachers, of which there is 7 of us physics teachers because it's a large school. And we sat down. I was like, all right, anything else we're doing, any other planning, all that stuff is out the window. We're just going to write. And from that day, I was just like, these resources need to be to a standard to share with everyone because I've got a feeling that there's going to be nothing. So we need to make this good enough to share. So when making it, have that in mind. Everyone did probably about 20 to 30 hours each over that time until the end of term. And then we had basically the structure of the lessons, which is about 30 lessons. And then I spent about between 40 and 60 hours in the holidays kind of fixing it up. So the plan was to have it perfect by the end of school. I knew I was never gonna. But then a few things came to light. SLOs finally arriving. Just everything requires more time. I think Boxing Day was not a fun day, if I recall. I can't remember why. Something happened on Boxing Day. But the point is, all of that stuff happened. I wanted to get it done before school started. There was a lot of hours. It was all from term 4 until day 1. In answer to the second part of your question, my teachers have not used it yet. Like we're not a pilot school. These are totally untested, right? I'll repeat that because it's super important. We are not a pilot school. These are totally untested. And in fact, that we haven't done this yet because we're going to be either the third or fourth standard this year. So it'll be sometime kind of term 3. So I think we might even be the 4th one.
Okay. In what time frame of like uh 2/3 of term 3? Like, do you have a certain number of weeks you're trying to get this done in? So
Yeah.
7 weeks. Understood.
7 weeks. Yeah.
Cool.
So that's kind of why it was sitting around 30 because I was like, oh yeah, 7 weeks, 30 lessons
Yeah.
ish. But then it was and then David Houston was like, no, 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 this has got to be like 20. And I was like, what? How am I going to do this in 20? So I chopped it down to 21 plus 8. But 21 essential and 8 optional.
Yeah.
That's basically what I love doing. Um, Electricity got a major cut because after talking about the SLOs, we realized that we didn't have to go as deep and teach everything, and we could push stuff on to level 2. But basically 7 weeks. We plan to do
What's
it.
your plan for staff training before the beginning of this 7 week?
I'm gonna do probably about 2 to 3 sessions. One of them, just like you said earlier, Dave, like some snacks, although not in a science lab. And then around the outside of the room, just all the different experiments that we do and all the demos, and just have physics teachers spread amongst them and just have people do a big old loop over an hour and actually try some of these experiments and get a taste of all of them as one of the sessions. We're going to do another session on specifically energy bar charts, it's a system, like just a whole session on it and practicing it. And then I might end up doing another one. I'm not totally sure.
Yep.
But that'll be obviously it has to happen somehow before we actually do it. I think the hardest part is getting teachers to really get that it's kind of new. Like it's old, but it's new. Like it's this material isn't actually and really obvious. Like the understanding of energy like I learned a lot in creating this course, you know what I mean? And I've been a teacher for 12-ish years. You know, I've got a master's, you know, I learned a lot. I was like, wait, it's in transfers. What are we talking about? I thought it was an energy type. And I was like, oh my God, I'm learning stuff. Damn it, I didn't want to learn. Anyway, any other question? Or should I just
No, that's good. You've already hit a few that are already there.
go? Keep interrupting, it's fine. Throw them at me. I just wanted to talk about these magical things called these optional lessons. Like I said, we had 30 lessons and I was told I had to have it be closer to 20. So these ones, you could teach the course in 21 lessons and the kids would be able to pass the exam. Yeah, like you'd be able to cover the material. When I say lessons, you really, really want to put in work periods in there. You know what I mean? Because otherwise they'll die. But anyway, there's these magical optional lessons which I just couldn't cut. They were just too good. You know how it is with physics. They just so like, for example, that first one, it's just energy engineering. You're shooting dice. It's like a building activity. It's quite fun. It's just I couldn't cut it. It's just too much fun. Number two is actually a really good energy simulation experiment. So it's using the FET energy and a couple of them actually, like the roller coaster type thing, and also the person on a bike. Have a look. It's really cool. There's so many different thermal experiments you can do. Like lesson 3 to 6 is just ones I couldn't, like you can just keep on doing them all day, you know what I mean? And it's really cool for the kids to be experiencing heaps of different experiments, you know? But if you don't have much time, you could cut them. But if you got time, just keep on doing them, right? They're all there. There's heaps of them, right? 3 to 5, 3, 3, 4, 5, and 6 are those. 7 and 8 are just like you could cut, but they're quite high level. Like specific heat capacity problems, like it just goes through a really intense problem, and the applications of heat, of latent heat, talks about like heat pumps and stuff like that. It might be like, feel free to skip, but it's just if you want to go a little bit further, it's there. If you've got some super extended kids, it's there. Like give it to them. I, just like some of you, have been going to a lot of these sessions, and there's just a couple of hints from literally a week ago if you missed it. So I've been watching these sessions going, oh, I'm going to add this to the lesson, or I'm going to teach this in this way. The pilot schools, some of the things they were saying, one of them was keep on going back to the basics, right? Just assume they don't actually know anything. I mean, I'm teaching level 2 physics, and I'm like, oh, are you sure you did mechanics? Electricity, like I'm lucky because we do like a whole thing on electricity in year 10. So they've got some electricity. So it's not too hard doing electricity in their 4 lessons, but I'm probably still going to assume that they've forgotten everything. In terms of the particle model of matter, what the pilot schools was saying was just take it all the way back. Like solid, liquid, gas. Let's start all the way here. There's some particles in there. When they're solid, they're stuck here, and you're like, you just got to go all the way back. But luckily, these lessons, we kind of bring it all the way back, but just know that you're going to have to go that way. I mean, I was in a level 2 science class today, and they were like, I don't know how to describe particles in a solid. And I was like, come on, you know this. What they're also saying was what was it? You can cover 1.4 in material in different standards. So they were saying the thermal stuff, like some of that stuff you can jam in, I think it's 1.1, I think it is. And some of the mechanics, like you could totally cover it in like 1.2, right? In some of those experiments. And that way you could do a chunk over there and a chunk over there and not do what we're doing, which means that we're really jammed for time because I have to do all physics in one chunk, right? Problems I likely foresee to happen. I've already talked about staff PD, just making sure that those staff are there. And I really feel like this sounds stupid, but just trying to make them really see that they actually may not know physics, but I think they'll figure that out later on, I suppose. And one thing which, because we aren't a pilot school, you're probably going to find that some of these lessons might be a little bit academic. So you're a teacher, you're gonna have to like differentiate some of that learning, scaffold it, because some of them like, yeah, it's written quite academically. I mean, there's the lesson on the system might just go right over their head. It's pretty intense. But I was just like, I really need to put a whole lesson in here on the system just because it's really in depth and interesting and just like there's real concepts in there. But since I've been looking back, I'm like, man, that's actually going to be really hard for them. But I'll leave that to you. And again, untested. So my reminder to you is this. If you forget everything from this whole session, all you remember is Dave's beautiful face and you've forgotten everything else. Okay. Just remember, go back, read this document, just read it, steal what you want. It's all there. Make up the rest. It's basically it. Does anyone else have any other questions?
Let's see. One question that we didn't hit. In your school, how many lessons a week?
Level 1, 5.
5 a week. Okay, so you're one of the few that's still running every day. All right.
Yeah, but 9 and 10 different, but 5.
Yeah, but at year 11. Yeah. And logistics wise, I'm curious. We've got 9 year 11 classes, and we decided as a timetabler, I floated the idea to my department to keep our technicians from losing their mind. When we were all going to do, let's say, chemistry for a term, wouldn't it be great if there were only 2 labs with all of the classes and the teachers would just rotate through, but the gear would be there for you if you had, wants and needs for practicals and demos and activities and experiments. You said you're at a massive school. How are you going to manage the gear to go from A to B to C?
Basically, I'm just going to hope that the technician fairies are going to make magic happen. It's just going to magically appear everywhere at the same time.
Yeah.
But in seriousness, because we've got this happening with year 9 and 10 at the moment.
Yeah.
We have wondered. The main thing we're doing is just ensuring that, because at any one time the most classes that are doing it at the same time is 3. Which means we need to make sure there is at least 3 class sets of whatever we're doing.
Gotcha.
And that's currently all we're doing. Like any other timetabling, switching is almost seems like too much of a headache because it's like 12 classes and some of them aren't even in the same room in every period. It's just like,
yeah, it gets complex. So
yeah, so like basically it'll be a set of equipment on a trolley that just goes kind of over there and then kind of over there, or 3 sets, sorry.
yeah.
There is a couple of experiments where there literally just isn't, and it'll be like 2 and 1, and of a different experiment, they just have to communicate.
And if it's anything like us, I'd be curious if any of your staff decide to reorder things. We had some that one of our chemistry teachers decided to say, "Oh, I'll start in the middle because I like this part of the topic." And we're like, don't the kids need to, like, as you said, when you were planning it up, you were learning, saying this sort of has to come before that because of reasons. But sometimes you have staff that decide, oh, I like teaching it this way instead of that way. So the myth of freedom can sometimes become an interesting.
Yeah, just make sure they don't have it. I mean, like, I think that there's only 3 physicists who might be the problem who think that they might actually know, but in being heavily involved in designing the course, they know that most of those concepts are introduced in mechanics. I mean, if they threw thermal before electricity, to be honest, it wouldn't be the worst.
Yeah. How long are each of your lessons? Are they hour, 45, 55?
About 50 to 55.
Understood.
About 50.
And what else do we got here? somebody was asking where they find all of this content inside the NZIP secure server is the short version. And if Zoe, if you need more information, just ask. And for the people who are watching this in the future who can't ask any questions, we should overtly remind them inside the NZIP secure server is a folder with your stuff inside of it.
Am I right that currently people's login still works for a little while? Or is
Yes,
it
as far as I understand, I think
like
David,
last year's?
yes, last year's 2023's login are still active. That might change after Easter at some point in time. But it was just basically to, like, as you said, help everybody this year get the wheels spinning.
Yeah.
Yeah. Anybody else have any questions? Aaron, feel free to stop sharing your screen if people really want to see each other. And
Yes, I can
we're
totally
getting
do
a
that.
question from Matt here while you do that. It says, you said you insert your textbook questions here. He's asking what textbook or source or practice problems are you planning on using?
Well, since you asked, I feel free to unshare me while you're trying to find out how to unshare me, because it's like that's what I'm seeing. Your question was what book am I using? We in we have the SciPad, the new SciPad. Oh yeah, cool. The new
Yep.
SciPad, which was kind of put together near the end, they were like kind of put together parts out of the different standards that were put into the current order of how it is. And a lot of the stuff is quite a good fit. The main thing is like, so we bought effectively a few class sets so that we can give relief, cover
Yes.
work really easily. And also if we ever want to do some problems, like really simple problems to do with just the standard stuff is totally in there.
Yeah.
So that's the book that we're using currently.
Yeah, because you do need to have some prepackaged stuff for random relief.
Oh, like
You can't expect another science teacher to fall from the sky just to keep the wheel spinning while a person is sick or dealing with a sick kid.
yeah, and in a new course, like everyone's like, I don't know what to give them. You know what
Mm.
I mean? Like otherwise it'll just come down to those three physics teachers. Whereas that book covers, 90% of everything you need. Easily go work on this page for that period.
How much of the experiments have you actually tested out and measured and acted like a kid and did? Because that's always the case when you're coming up with new experiments.
In out of all of these ones, because it's seven teachers who've been putting it together,
Mhm.
I have done most of them just through my experience. I think there's one experiment out of that which I have not personally done, which I'm planning on doing over the next couple of days,
Mhm.
just to make sure that I can demonstrate it to all my teachers in the PD.
There you go.
But all of them are tested as in tested by teachers in our team.
Yes. Cool. Anybody else have any random questions or thoughts for Aaron? It's an amazing package, and I will, on behalf of everybody, thank you for your extreme generosity of sharing it, because that's a huge, massive thing, my friend.
My pleasure. I'm glad to share.
Let's see what else comes to mind. So you mentioned your school's got 12 NCA Year 11 courses, and you're rolling 4 standards each.
Yep. Oh, no. Sorry. We're covering 4 standards worth of material, assessing 3.
Ah, okay. Interesting.
The, the chemistry one, they're not assessing, they're just teaching the content, if that makes sense.
Yep. Um, do, 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 do. Just trying to read some questions here. So, let's see. I think Carrie asked a question back here. Was one of the lessons on Hungy enough to embed your specific capacity idea? Like, because you're trying to trim and saying you got to go between things. Because one of the occasionally I did think I hear you said that one lesson could span over or two lessons.
Oh, definitely. Like, when I say a lesson, sounds like a contradiction, but a lesson may mean 1 to 3, in the
Periods.
sense that like you gauge your class, right? If you feel like they're nailing it and it's going really well, one lesson, totally, right?
Yeah.
Like, um, if I'm getting halfway and I'm like, I've hit a wall and these kids is really not getting this concept. Let's try some problems. It's like work on this. Um, it could easily become more, and I'm pretty sure that something like specific heat capacity would um, end up being one of those types of ideas.
Yeah.
It's the Hanging Stone lesson is actually covered over 2 lessons, and then but that again is really brief. It'll just be like 2 lessons. Here's the content. Here's an experiment, and I'll play chucking a lesson, doing some problems, and that's if I was packed for time. If I
Yeah.
wasn't packed for time, there's about a bunch of other experiments that I probably just keep on putting in there to give them experience.
Yeah, you do sort of need to come up with a new set of nomenclature for you have periods and you have lessons. And you have 5 periods a week, but
Yeah.
lessons could overlap periods, is what I'm hearing.
Yeah. Oh, 100%. Like, a parent was confused yesterday when I was emailing them because I was like, yeah, I've got those 12 lessons cover mechanics for level 2. And they were like, what are you talking about? That's a term. I was like, oh, yeah,
Yeah.
right. All right.
Yeah.
Not 12 lessons. It's actually,
Yeah.
you know,
12 chunks. Yeah. Rather than
40.
calling them a lesson, they're sort of like chunks or whatever. Yeah.
Yeah, like you as the teacher need to gauge whether you can move on or need to put on problems, whether you need to give them homework problems to practice, like
Mm. Yeah.
something
That's
as
what we
hard
did.
as
And
specific pers
while we were going through our own version of thermal for the
yeah.
3.5 weeks that we did it, we had to magic up some practice questions along the way because, when you're flying the plane, you realize, oh yeah. So furiously at interval or lunch, and then the other teachers can use it. So yeah, that's always part of the game when you first drive a course. Yeah.
Mm, yeah.
Carrie is also keen here to say she's keen to know whether you have teachers who, as the quote goes, they know all about energy. So, and do all the old school style energy conversions.
What do you mean by old school energy conversions?
Oh, Carrie, you might have to turn your
Okay,
mic.
I'll turn my mic.
Yeah, curious.
So that the traditional, well, what you see in some books is like in the in the hydro scheme, gravitational potential turns into kinetic energy, which turns into electrical, which turns into, well, actually they usually leave it there, but with the energy bar chart system, it's like, well, look at the whole thing. I've got my toaster on at home. That's heating up my toast. There's thermal energy there, hot toast. It's coming actually from the falling water, and everything else is just in between. And there might be some heating, but this sort of using energy bar charts to really kind of map out the energy a little bit in a little bit more scientific way. I don't. I'm just concerned that at my school, some of the teachers will look at it and go, "Oh, energy, that's easy. Just label it and move on. You just got these labels. Slap the labels on. That's it." And I don't know if that's going to happen, but it might do.
I would say my school definitely pre the conversations I was having, nobody had ever heard of what an energy bar chart was.
Exactly.
And it was very, very much that the old school style view. There was definitely some Sankey diagrams going on, which is all well and good. But that's why I'm definitely going to have to be running some PD is just to go, all right, let's practice these things like energy bar charts so we can really explore what's really happening.
And they're okay with that. They don't go, "Oh, why are you making it more complicated? I knew this, and now you're confusing me."
I haven't done the PD yet,
Okay.
so I will say that they, they don't get a choice. they go to the PD. But the school of my in my science department, they're all, or most of them, are really open to learning. But I suspect, just secretly between just you and I and no one else, that
Video's not on it. Oh no, it is actually.
of course it is. I suspect that there'll be there's always going to be some people who just totally think they know what they're talking about.
Well, that's people, isn't it?
But I mean, like I said, I also just totally learned quite a lot by creating these resources. Yeah, I was just like, I thought I knew what I was talking
I'm
about.
also interested, while you've got me unmuted, is to know your school runs compulsory PD for all the teachers on the course. In what time? How do they do that?
So just PD in general, what time? Like how much?
Well, I know you have PD time, which is for faculty curriculum input, looking at this stuff.
We are taking over our department meetings.
Okay, so your department meeting time is used for PD on this stuff.
Will be, oh yes, and will be. So it's basically about
Cool.
an hour every 2 weeks.
Yeah. Okay. Just interested. Thanks.
Yeah, no, totally. But there is school-wide PD that we won't be allowed to go anywhere near that.
Yeah,
On a
that's
different.
normal.
Yeah,
Thank you. I'll mute myself now. Should
that's all right, Carrie. I can tell you at our school, we used lunches and we tried not to use too much of the lunch. But yeah, it's just carving out time. And it's for the teachers that are teaching the course. Yeah,
Well, the
because
truth is, it's for the teachers teaching the course, but also any of the other teachers are going to be teaching the year after or the year after that. You know what I mean?
yeah,
Like, you kind of want to cover everybody.
exactly. Because you have the rotating map of staffing that your solution this year will not be the same as next year.
Yeah. Well, I mean, I say all staff, all science.
Yes.
There's no point kind of branching
Okay.
out too far.
I'm still a bit scared because until we see the exam,
Mm,
I'm just scared. Chucked a Sankey diagram into a test I gave my class just to see what they made of it. So see if they could interpret it without previously looking at it. Some of
and
them were okay, but some were a bit confused. But
yeah.
it was a very, very simple one. Because we don't know what's coming. We don't know what's coming.
Well, nobody does. That's the
Anyway,
beauty of the entire year right there.
there are some people at NZQA who know.
Oh, yes, but of course that's not ever going to be leaked.
No. Okay.
No. Any
Still
other
recording.
random questions? Sarah, you're asking for a screen share to see where actually the NZIP resources are. I can tell you that because we're recording this, the answer is going to be no, but maybe after we stop recording, we can play that game. Simply for obvious logistical reasons with people watching the recording later. Is there any other random questions before I stop recording? Because we are now reaching about the hour mark. All right, well, we will call this recording quits and then see what we can do offline. Here we go.